Hello everyone. Welcome to this YouTube video. I've made a total of four CX16 OS videos, so far. I guess it was a fair amount of time ago, but I kind of wanted to create this one to be a concise summary of the features and some of the interesting programming things going on here, and also so that you don't have to watch an hour and 20 minutes worth of YouTube videos to get to the gist of this. Alongside that, I just wanted to give a little kind of basic install or setup guide. There is a page in the docs, but I think some people enjoy video better, and it's pretty quick, so why not do it? For so you know, First off, I'll talk a little bit about X16 OS. It's a multitasking, preemptive multitasking operating system for the Commander X16. Terminal based, even though there's a little bit of a GUI, um, which we might be able to show. It's not, it's actually just the GUI just emulates a terminal, so you're just seeing a bitmap terminal instead of a text, you know, on the video mode essentially. I'm trying to, obviously I'm reading off bullets here, but I'm trying to recreate some of the userland features of Unix, BSD, Linux, all those, maybe, and try to take advantage of some of the features of the X16 just to make my not to make it more powerful like necessarily, but to make programming the operating system easier and programming programs to run in the OS easier. Um, so let's get kind of started. I'll show you how to get it set up. First, you're going to go to the GitHub page here. It'll be linked in the description if you need, but you just got to go to the release page. You're just going to want to go to the latest release. I'll show you the actual release page. The latest release, which is this one right here. We're going to want to download really just these. You can download the zip file, but I recommend just downloading the image here and this CRT file, which is going to tell the Commander X16 emulator what to expect. It will run without this, but some programs won't work. But this is a actual hardware cartridge, which the ROM, which you can buy, and there's kind of different versions of it, but any version is really supported. Um, but yeah, so just download these. You're gonna want to go to your, and this is also gonna presume you have the Commander 16 emulator installed. I think Box 16 works too. Anyone that, or actually won't, any version of the emulator that supports this 65816 is gonna work. The CPU that CX16 OS needs to run, which is not default on the X16s, but it will be on the next gen, which is kind of cool. Um, but so once you have that downloaded, you're going to open up your shell. You're going to download this out. You're going to, so all this stuff. But what you're going to want to run is, I'm just going to copy it from the guide. Okay. Docs. Obviously, you can run this too. I'm just going to copy the, makes it easier. Yeah, so you're gonna locate your X16 emulator. For me, it's in this location, and you're gonna add these flags here, and I'm also gonna add the RTC flag, and also this no mu command keys flag too, but they're not necessary. Once you get that, it's gonna open up in your other monitor, but you can bring it over here, and now you have it almost ready to go. First thing all you're gonna need to do is type you're going to need to cd into the OS subdirectory, and then you can just run the boot basic command, and it'll launch right back in. So this is the cx16 OS shell. Pretty basic, as you can see, but it does show you a directory. Sometimes I wish I gave the OS a different name because I always get tripped up on it. But let's show it off. So, right now I'm going to type some things in the command line. You can see obviously it's this appears on the screen as it should. But let's just run a ls command. very simple. Just shows the example files that kind of come with just like the default kind of installation here. You can cat one of them. So if I want to cat ipsum.txt, it's going to print out kind of an extended lorem ipsum, just as an example. You can see the screen scroll, and once it's done, it will stop. It'll give you back control. You can also cat ipsum and then run it with detach it, and then I can blind type here maybe, and you can see it's sort of gets, you can see there's two things, or for a second there were two things going on at once. Um, I just typed cat macbeth.txt, which is just the full text of the tragedy of Macbeth. I'll kill that with Control C, which you can do. You can do that on any program if it's not detached. So that's kind of some basic stuff. You could see detaching, and you could see two programs operating at once. Um, as a better example of that, maybe let's do yes, and we'll just do that. Oh, sorry. Let's do yes, and then ampersand it, and then we'll just, and then you can see things get printed out at once. It doesn't look as good as it could because of sort of the conflict. You can see both of them. I think I'm going to kill the command. All right, yeah, so what you saw there is that when you detach a program, you cannot kill it with Control C. So I had to blind type the kill command. Thankfully, or depending on your perspective, process IDs are reused. So you can kind of tell what process ID. So the first program here, the shell, is going to be process ID 16 or kind of 10x. And then your next program is be that plus 2, and so on, assuming no extra memory is used. So if I wanted to kill program 18, which is not running, but it will be the kill command when I run it, it does work, and this will work. If I try to echo the last exit code, it shows 128, which is the command, this was killed. If I just, I don't know, if I now do this again, it will show the status of the echo command, which exits successfully, and that'll be 0, success code. So that's some of the basics. Continuing on, some other cool stuff you can do here. Let's talk about pipes. So, there are pipes in this, or I've implemented pipes, so you can pass, text from one program to another pretty easily. So let's do a fun, I don't know how this is actually going to look, but I think it should look fine. So let's pipe ls into cowsa and see how it looks. Yeah, so as you can see, the cow is now telling us all the files in this directory, which is kind of cool, right? Guess it's not, if you're if you use an operating system that's been developed in the last, probably 30 years, this is not, particularly interesting, but on a CPU that came out in 1988, maybe a little more interesting. A 16-bit CPU with no virtual memory, or not really designed to do preemptive multitasking. Obviously, it was used in the SNES, but that was about it. Or that's not true. It was using the Apple IIgs as well. In that it was, I think that's where it was probably put to the best use. You could see some of the power there. And the SNES is always cool too. So, but at least in the multitasking, that's kind of where you'd expect to see it a little bit more. But let's look at a different chain. So if I want to print out all the programs we have here, we can print, the bin file, right? But if I want to sort them, I can do that. So now you can obviously see args, for example, is the first program because it starts with A, so on. But we can also pass this into the column. If I can type the column command, and that's going to print it out in a column, kind of what you'd like, sort of what like you see on a normal Linux, or at least when I expect to print ls in Ubuntu, this is what it looks like, or at least a large file. If you print been on a Ubuntu machine or something like that. So this is what I'd expect to see, maybe with 2 rows instead of you know five, or five 2 columns instead of five. But let's look at some of the other programs here. I think we can kind of work our way through. args is a very simple program, really a test program. It just prints the args back out. Not super exciting. But one thing I can show off is that the shell does let you use quotes to put spaces into one argument. So you can see there's a difference between args 1 space 2 space 3 and args open quote 1 space 2 close quote space 3. Assembler. That's a assembler. Um, but kind of selling myself short here. It's obviously a cool tool. Let's look at it. So we're going to cd into the code directory. We'll list our files here. Well, you'll see this touch.asm program, and if we cat the source code, or why don't we do this? I'll show you less, which is not a particularly exciting program, but it will show you the source code here. And if you wanted to examine the code for a long amount of time here, you notice, or even a brief amount of time, you notice is essentially the touch Unix command. That's why it's named touch. But why don't we assemble this? So we're going to assemble touch.asm, and it kind of just prints a bunch of debug that I haven't taken out. But if you now ls again, you'll see a.out, which is our compiled program. So a.out file name, let's say, and if we ls, we have file name. I'll delete file name because we don't really need it. But obviously now you can see what the file name, what a touch does. Let's actually do it again. Let's see if it will show ls-l. You can see that this file was obviously created at a different time than these other files. This is going to look a little strange. I think this is GTC. So yeah, it's not. I'm not recording this at 2:30. It's about 9:37. I think if you do the math on EST to GMT, that does work out. And then this is sort of weird, but let's clear that. We'll rm file name, and let's just do that again because I forgot what the programs are. So you've seen clear. I'll skip copy and move. That's about what you expect. Scripter. Scripter is obviously an interesting one. No one's gonna know what it is, but it's a kind of scripting language I designed to essentially be easy to implement in this OS and be kind of interesting to use, not like totally useless. So it's like kind of not quite. That's obviously not like Bash, but be able to interface with some of the shell stuff and do some interesting be able to do some interesting programs. So let's cat having table.sr is interesting. Not a particularly complex program, of course, but it shows off some of the features. Looping variables, calling shell, running programs in the shell. So let's look at this. So obviously we're defining or using these $signs. We're going to define these variables here. So you define star is 1, end is 13, and factor is 12. We're going to set, really I equal to start. So we're going to set it to 1. We're declaring our loop, essentially a label, which is actually just storing the line number as a variable. And we're going to now in this loop, we're going to set m to I times factor, and then we're going to print out I times factor equals m, and it will sort of like a shell replace those variables with the numbers. And then we're going to increment I, and then it's going to run this conditional. It's going to subtract I from end, so it's going to take their difference, and if it's non-zero, it will loop. So, or rather, if it's non-zero, it will execute this second half of this command, and the percentage sign here is just a goto. So if we run this with scripter table.sr, it will print out kind of the 12 times table. Obviously not a super amazing program, But we can, for example, it's not for show. If I change, oh crap, uh, didn't mean to do that. If I change the third line and I say factor equals 9, close out of there, right, and I sort of got ahead of myself showing off the ed program. But if we run this again, it will be, the timetables of 9 up to, 12. And obviously you can change these variables and tinker around. But let's look at some other scripter programs really quickly. You can also give args to a scripter program. So I think this is just gonna, it really just does what the args program does, or something very similar. 1, 2. So you can see the first argument here is hello world, one argument because we quoted it, and then 1 and 2. Pretty similar to obviously the args program. Oops, typed, but you get the idea. So you can, obviously interact and kind of make interactive programs. Another thing you could do is take input from the user. So if I run demo.sr, it's going to ask me to enter file name. I'll just give it demo.sr, and it will actually just run the program X16 on that file. We'll just print it out to show you what I'm talking about. So we're going to define program here at XXD, just so we can, you could change it theoretically if you want to. We're going to print out, enter a file name. We're going to take input with this kind of caret into the file name, and then we're going to run some system routines to open the file. If it is open, or if the file does exist rather, we will run probe, which is xxd, to run a hex dump on that file name, and otherwise it will just print an error. So if we give it a file that doesn't exist, it will, not be able to open that file, and it won't even try to run xxd on it. But hopefully, those are kind of off to a good start here. Obviously, we have ed here, which is the default Unix text editor, or was, and it works pretty similar to the version on Unix. There's no visual mode at the moment, something I would hope to do eventually. But obviously you can see you get some of the features here. You can delete lines, like if I want to delete these first 3 lines that I print out, let's just do 1 to 10, so I don't have to print out the whole line. You can see that those first 3 lines were deleted, and most of the kind of traditional ed commands are here. There's no regex match implemented currently. I think I might be able to do that through the grep program, which I'll show later. It's sort of a separate program because of some of the memory limitations. So yeah, but it's definitely it's cool for editing files, and you can definitely program on this machine if you wanted to. Obviously I do most of my development or not obviously, but I do most of my development on a cross compiler essentially. But we'll quit out of that, and we'll show. I do want to show cow say I like her. I think the cow's cute. That's about it, but I think it's it's a fun we're going to have. Oh yes, actually. So LS does let you print with there's different options, like you can print with timestamps, or you can print in color and classify, stuff like that, or LA prints LS-A prints all the files. If you do ls-a, there's no difference, but ls-a prints all files, and then ls-I prints all files except your includes dot files but not dot current directory, and parent directory. But what you can do is alias commands. So you can, alias ls-cf, and now ls will always print out in color and classify those files. I'm actually going to exit and reboot real quickly, and we'll right. So now we have a little. That's okay. So this is the font program. It just uses the GNU Unifont to give your text characters a little bigger, then increases the vertical size of those characters. But what I wanted to show is that you can run dot files, or not dot files, but you can run script files in Bash, or sort of not Bash, Shell. Don't mess up my typing. Now, if I get that file to show what we just ran, we just ran 3 aliases. ls now aliases to ls dash color, classify, and obviously you can see directories green and files are green, or files directories are blue and files are green, and the slash and the amp or multiplication or star. Oh my god! But you can also run ll to do ls-l, but it's also classifying because it also replaces. And then la does that. I don't actually make dot files. So if I see here, if I ls, it's not going to show any files. But if I la, it will show the dot file. And obviously I do ls-a. Sorry. And if you do ls-lowercase a, it will show all files. If you cd with no arguments, it takes you back to the home directory. So let's keep on going. Kind of breezing through some of these programs here, but obviously the point of this is to kind of be a programming challenge. I don't, necessarily expect everyone to use this as, as their daily driver operating system. But I think if anyone gets enjoyment out of this, or can look at the source code and find, learn about system development, not that I'm an amazing programmer, particularly in this space. Obviously, you can see the bugs with, text printing at the same time gets, colorful. But you can see some of that stuff. Yeah. So why don't we look at? I don't know. I like the export. We can look at date. Prints out the date from the real-time clock again. It's 9:47 here, but it is UTC, so it goes a day ahead. And you can also print out with the arguments, which I do not remember. I think this is going to be bad. Okay, so yeah, there we go. I got one to work. Plus, because it tells you, you're doing a kind of argument, and then or percent sign M is the month with the the 0 prepended if it's less than it's before October. So you can see that kind of stuff. I was going to show calendar. So you can see cal program cal just prints out a calendar based on your arguments. By default, I think it just prints out the current month, August 2025. You can also set it to be any year or any year. You can do 2025. I think you can do month like 7. Okay. I actually somewhat interesting is I ported this over from the source code for the BSD version of cal. So not to shove the load over, but I think what's cool about that is that I'm able to port programs without majorly modifying the source code. Really, what I had to do is implement some macros for like the error function that's traditionally defined, but you can essentially define it as a macro that calls like printf and fprintf and then exits depending on the arguments. But there's other programs like that. So the expert program also works like that. So I can do 2 plus 3 times. So you got to make sure there's spaces between every argument because it is particular about that. That's kind of the POSIX thing, but obviously it's also simpler to implement in software. But you can do different stuff. It's obviously floating point. here, but you know, there's other stuff you need, and obviously it does math problems, which is kind of nice. Give it a second. Oh yeah, man. So man, obviously I think everyone's familiar if you got it this if you made it this far. But there are a few programs that you can run the man page on. One of them is man. It takes a sort of a takes a version of like nroff or troff that I implemented myself, very simplified version, and just passes it through less, which is essentially through your man pager, which is in this OS's case defined in the assembly source file, but you could define it to be any other program. But you'd have to, you'd have to recompile instead of, changing a shell variable, which is obviously more involved. But you get some of the functionality there, and obviously most of the time you just want to pass into less. But this is a very simplified man page. It's really not even much there. But you can do, like, if I try to man in section 3, it's not going to work. But if I say man in section 1, since it's a program, it will work. And I can also man rep. Honestly, I don't remember what program. Yeah, so there's a few programs here, like ASM. You probably don't know all the syntax there, so I decided to make a man page for that. Man, scripter. Also, obviously not a it's a novel program, so you're going to need some help writing a program for this. So here's there's a syntax guide, a very basic one, but hopefully you'll be able to figure it out based on this, or at least have a clue. But I did kind of spoil a little bit, but we also have a version of grep. Also talked about it with Ed, but it's what you would expect. Um, you can search for files for text. This case we're searching through the play Macbeth for Macbeth. So it's basically going to show every time he enters, exits, or speaks. Um, so it's actually less than you'd think. Also Lady Macbeth, because it's obviously not attached to the start of a line. But hopefully I think that's interesting, and it's a pretty cool program. So we can do it with something else. I tried this before, but I'm sure the lines in this Lorem program are quite long, so it will. You kind of have to search out the lorem inside the line. You can also use the -n to print the line numbers. So it's going to print on line 1, obviously, because that's how it starts. And I can also do, you can also do a case-insensitive search. So let's do Macbeth again. In this case, you'll show every time he's mentioned, because obviously a lot of times it's just going to be the capital M that's capitalized when it's not a stage direction. So you get a lot more results here. So kind of the two flags that are implemented, along with I think -H to give you a little help screen. But hopefully this is a little cool demonstration of rep. Obviously this is a very involved program. I implemented a pretty essentially an NFA state machine simulator in 65816 assembly, which was a challenging but a fun project, pretty cool. It was right before I was taking a class on finding state automata, so it was actually helped in that class, ended up helping my understanding, which was kind of nice. Let's keep on going through these programs. I think we only got a few left that I want to show off today. I'll do an easy one. Sleep. It sleeps for a given amount of time. So if we sleep for 10 seconds here, it will, do that. Actually, we'll give it a sec here until it finishes. And I can even time the program. We'll do 3 this time though. It will be a little off, I believe, because of some of the startup. In this case, really off. Let's try sleep 5. I wonder how if it's off by the same amount. Okay. Not exact. Could be an emulated thing, but it does work on hardware for the most part. I already showed off the sort program. Obviously, pretty useful for sorting text. You can sort. I don't have a good example of what you'd want to sort. Just a text file. But I guess I could sort like all the lines of a program. What about touch types? It's not going to be very interesting. It's just going to be, you can tell, you know, you see this tab space here is less than a period, which is less than all alphabetical characters. So it's kind of interesting there. You see all the lines that are tabbed up at the front. But we'll print out. You can also tell this is not instantaneous. It does take a second to sort and then print the columns of pipes. It's not super slow, but it's obviously on a 8 megahertz machine. It's not super quick either. You can do some cool stuff like printf. You know what it does, so I'll skip it. Print font prints the character set. Not super interesting. You saw time true exits with return code 0 as the it was the easy picking to implement. So is false. We also have word count, which I can just type here. You can use Control D to end the input to a program. So we had 2 lines here and 13 characters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. With the 2 new lines, but obviously you can do word count there. And I think that's about it for this, kind of demo here. It's not gonna look right, but I hope this was interesting to watch me go through. Obviously, there's a lot of programs here that are less useful than others, and some are more useful. Like Ed's probably one of the more useful ones. Grep maybe. I gotta show off NeoFetch, of course, which is obviously the main similarity it shares with NeoFetch is just the graphical display. It's not a particularly closer to NeoFetch than any other fetch program, but you can see all the colors there. You got a little design, not designed by me, so shout out to that guy. But you can see all your programs here. Just counts the number of programs in that folder. Your shell, some of the stuff's hard coded, like CPU. There's only one CPU that it runs on, so I kind of took the shortcut there. But I will show on tar, which was a program I was able to port from just like an open source implementation. So we'll untar out.tar. It's a very basic tar file, but we can show here, and we exported 2 files here, or we extracted 2 files from the star file, text.txt. It says you unwrap the tarball, and we did. So you can tell it was success. And then empty file is in fact an empty file. We'll word count it to show 0. So those were the programs I kind of particularly wanted to show today. I guess the question is why program this, and I'll talk on that a little bit. This started a long time ago when the X16 was I didn't even have one in person. It was still I don't exactly know when, but there weren't even hardware prototypes outside like the 8-bit guy and maybe a few others. But I wanted to kind of learn, I enjoyed programming in C and assembly. I'd written games for the X16. And I wanted to do something kind of more interesting, something that no one had done really on many 6502 platforms. I mean, there's like GeckoS and Linux, that's what it's called, that are run on 6502 machines, and you could probably adapt to run on the Commander. And they're probably a little more full-fledged and more accurate to being a Unix kind of that environment. But I wanted something that could kind of take advantage of some of the X16 features. At some point, maybe have a GUI and be easier to program, simpler to program, have unified memory map, stuff like that for programs that you couldn't, you don't really get. I want to be able to program on this and to run programs on this that you have written in the OS, and you can't, and to my knowledge, is not really super possible in Linux. Could be wrong. But I do want to see if this will work. That's actually might work, right? Oh wait, okay. Yeah, one more try. Okay, there we go. So this is I'd say we might be able to show this off, and this is basically an example of sort of the hook system, which is basically a way to a program can basically redirect standard in into essentially a pipe for that program, and it can do interesting stuff with it. So in this case, it's actually two programs running in conjunction to print to a sort of virtual kind of text display, which is actually a bitmap. Um, it really does not look very impressive, obviously, because it's black and white, and it's you can't move this window around, but behind the hood, it's a little, you'd see it's pretty cool. And it was somewhere I wanted to go more strongly originally, and then it sort of kind of to me it was a dead end. I wanted to work on other features, and foremost, and it was figured I'd be running against the limitations of the OS, so I decided to sort of focus on other things. But I still think it's kind of interesting, and somewhere I still want to explore. I think now that I've sort of made it more capable, the OS is more you can just more stuff you can do than you used to be able to. I think this originally was on when it was still a 6502, ran on 6502 processors. So I think there's a lot to explore with this. But, again, coming back to why programming this, some of it's fun. I mean, I enjoy programming this. It's hard. I got, there's a couple times I spent 7 hours tracking down a bug. I know one time it was actually a problem in the emulator, which was extremely frustrating at while debugging, and obviously a little even arguably even more frustrating when you figure it out. It wasn't your fault, uh, but also I was able to contribute to the emulator after that, so I did accomplish something for others out of that, which was cool. Once I was able another time I had something working on the emulator, didn't work on hardware, but found another bug with the emulator. In that case, I still did something wrong because I did not understand the hardware behavior. But that was still, obviously a pretty cool thing to figure out, in retrospect. But put a lot of my work into this, obviously over 3 year, really 2 years of college. Not full time, obviously, but in and throughout, kind of different periods when I was free, didn't, wasn't studying, whatnot, doing other things. But it's been a really exciting project. I wanted to show off in a more condensed video. Obviously, it's not the most condensed. It's approaching 40 minutes, and the rest are about an hour and 20. I don't even know what I'm going to probably title this video, but I think people, at least hopefully you made it this far, haven't turned off your camera. But yeah, I'll wrap it up there before the 40-minute mark. Thanks for watching, everybody. This is cx16 OS. Again, if you want to tinker with this, link to the GitHub will be in the description. If you want to contribute, please feel free. It could be man pages. Honestly, I have like 6, and there need to be more. So if you want to do that, I'd be really appreciative. Just kind of so you can figure out stuff that wasn't just looking up the instructions online. I'm Cameron, student IU. So check out my GitHub, whatnot. Obviously this, and there's some other games for the X16 which I think are pretty fun. So, anyways, take care, everyone. Thanks for making it this far. Have a good night, or evening, or morning, however you're watching this video. Take care, everyone.